Okay, so this is your note packet that I put on your desk. We're starting with the first page. Okay, so I said put that in your journal, but really you can keep that little peach sheet out because we're going to use it, right? So if you need to look at that to help you remember the rules, I'm going to try and write the rules. So if we're multiplying exponents, remember, if the base is the same, what do I do with the exponents? If the base is the same, so, oops, when you multiply, if you have the same, I don't know why that's not showing up. Give it a second. If you have the same base, you're going to add exponents. Same base, add exponents. Okay, so let's start that. First example, that becomes x to the 5 plus 4, which is what? X to the 9th. Questions about that? This next example, negative 3 parentheses to the 3 plus 2 power equals negative 3 to the 5th. I want to write a special note. When you raise a negative number to a power, meaning you put an exponent on the outside of it, you must use parentheses. Because if you don't, you're just taking the number to the power and the negative kind of travels along for the ride. Have to use parentheses when you're taking a negative number and raising it to a power. That is a very, very, very important rule. Okay. I'm going to skip number 4 because it's just like number 1, and I'm going to go to number 5. And I'm going to rewrite this so you can see that you really have, I'm going to try to group them together. You have m cubed times m, those are the like bases, times n squared times n to the 4th. What do I need to put on that m that has no exponent? A 1. So my final answer becomes what? M to what power? N to what power? 2 plus 4 is 6. Okay. So when you multiply, you add. Multiply, base is the same, you add the exponents. Luz, pick your head up. Pick your head up. Let's go. So let's talk about dividing. What happens when you divide? Yeah, if you have the same base, you're going to subtract the exponents. Okay, so example number 7. What's that become? What does 9 take away 3? So x to the 6th power. Example number 8. Be really specific. Let's see. Leslie, example number 8. What does that become? I'm subtracting because I'm using a division problem, right? Negative 3 in parentheses to the 2nd power. Yes. 4 minus 2. I'll write it down here so you can see your work. Negative 3 to the 4 minus 2 equals negative 3 squared. Okay. I'm going to skip number 10 and I'm going to go to number 11. The filled out notes are up there so you guys can see it. I'm going to go to number 11 because, again, I want you to see that there are 2 terms that we're subtracting, 2 like bases. So when I rewrite this, I really have f to the 10 minus 9 times g to the 7 minus what? What should be on that g in the denominator? A 1. So what do I end up with? F to the what power? F to the 1st power. Do we typically put a 1 there? No, so I'm just going to write it as an F. Times g to the what power? G to the 6th. Okay. Now we're going to talk about 0. Anything, any number, any non-zero number to the power of 0 equals 1. So example number 13, 3 to the 0 power is 1. Example number 14, negative 3x squared y to the 5th. The quantity to the 0 power equals 1. So now we're going to talk about some negative exponents. Remember, when you have negative exponents, I want you to drop it positive. Just think of dropping it positive. Write it as a reciprocal. So x to the negative 2 power is the same thing as what? 1 over x squared. Good job. 8x to the negative 3 power. Pay very close attention. What is being raised to a negative power? The x. So the x is what gets moved down to the denominator. The 8 stays in the numerator. 8 over x cubed. 8 over x cubed. Okay, going to the next page. Number 9, what is being raised to the negative 3 power? Yeah, the whole thing, the whole grouping. So I'm going to rewrite it as 1 over 8x, and I'm going to keep it in its parenthesis to the 3rd power. Yeah, that's fine. I think your packet probably says number 18 on it, doesn't it? Yeah. I renumbered them a couple of, I started just deleting problems. So, because we had too many. So the next one probably says number 19 on your packet. So 5x to the negative 4, y to the 0. So what do you want to do first? Let's talk about this. What does this become? So this is the same thing as saying 5x to the negative 4 times 1. What is anything times 1? It's just that number, right? So I'm ignoring it. Who cares about the times 1? What do I have to do next? What's being raised to the negative power? X. X is the only thing that's being raised to the negative power. So the 5 stays in the numerator. The x is the only thing that's being negative, right? Because remember, there's a 1 there. We just don't write it. So 5 over x to the positive 4. 5 over x to the positive 4. Now let's do some division rules. So when we divide, remember, we subtract. So when we divide, we subtract. I'm going to skip number 23 because it's just a multiplication rule. I'm going to go to number 24. So this becomes f to the 2 minus 7. Cannot leave my answer as a negative exponent. So what does that become first? What is 2 minus 7? Negative 5. So f to the negative 5th power. But I can't leave it as a negative exponent. So what do I have to do? Put it down in the denominator. 1 over f to the positive 5 power. Number 25. So let's worry about taking care of this fraction first. Let's reduce that fraction. So what does that become? I can divide both of these by what? Yeah, I can divide both the numerator and the denominator by 5. What's 10 divided by 5? 2. And 25 divided by 5? 5. And then I'm going to use my rule, dividing the x bases. So that's going to be 7 minus 9. And my z's have a 1 next to them times z. Oops, I started writing an x. Sorry. Times z to the 1 minus 1. Okay. So let's see. 2 to the, what is 7 minus 9 for my exponent on my x? Negative 2. And 1 minus 1 for my z is what? Okay. All over 5. What is anything to the 0 power? So I'm just going to ignore it. Just ignoring that because it's just times 1. What do I do with my negative exponent? What do I have to do with that? That has to get moved where? To the bottom. So the only thing I have in the numerator is the 2. In the denominator, I have 5x squared. Does everybody know what a bunk bed is? Okay. So when I think of negative exponents, I think of a bunk bed. If the negative exponent is in the top bunk, I need to move it down to the bottom bunk to make it happy. If the negative exponent is in the bottom bunk, I move it up to the top bunk. That's just it. Think of it as a bunk bed. Okay. All right. Multiple operations. So for example, number 30, what do we have to do first? I have to distribute the power. I have to distribute my power. Distribute that exponent. So that becomes 3 to the 1 times 3, which is 3. B to the 2 times 3, which is 6, times 2b to the 7th. So I'm going to have to multiply those coefficients. I'm going to have to multiply my 3 cubed times 2. I can put that right in my calculator. 3 cubed times 2, or I can simplify 3 cubed to 27. So I have 27b to the 6th times 2b to the 7th. 27 times 2 is 54. B to the 6th times b to the 7th becomes b to the 6 plus 7, which is 6 plus 7 is 13. So 54b to the 13th. 54b to the 13th. I'm going to do example number 31, and then we're going to move to the word problems on the back. So number 31, what do I have to do in the denominator? Yeah, I have to distribute that power in the denominator. The numerator doesn't change at all. I'm going to put a 1 next to my negative 2. So this really becomes parenthesis negative 2. Close my parenthesis. 1 times 3 is 3. So negative 2, the quantity is raised to the 3rd power, times x to the 3 times 3 is 9. Okay, so I'm going to simplify that right here. Let's see. 32x to the 8th over, what is negative 2 times negative 2 times negative 2? If you put it into your calculator, make sure you use the parenthesis. Negative 2 to the 3rd power is what? It is negative 8. X to the 9th. So the rule says that first you're going to divide your coefficients. 32 divided by negative 8 is negative 4. Then the coefficient rule says if the base is the same and you're dividing, you subtract the exponents. I don't have anything in the denominator now. I'm going to put a 1 there. What is 8 minus 9? So I end up with negative 4x to the negative 1 power. Can I leave it like that? What do I have to do with that negative exponent? Drop it down to the bottom. I'm going to drop this down to the bottom. So I have negative 4 in the numerator, x to the 1st power in the denominator. And I'm not even going to write the 1. We don't even need to write that. Okay. Flip over. Okay. So we have some exponent rules. We're using exponent rules to find area. This first shape is a rectangle. It's a rectangle. The area of a rectangle, the area formulas are written over on the right. Length times width. So what does that mean? What am I really multiplying? 11x times what? Times 3x. So I have to multiply the coefficients. 11 times 3 is 33. If the base is the same, remember there's a 1 attached on each one of these. If the base is the same and I'm multiplying x times x, well, that's to the 1st power. 1 plus 1 becomes 2. That's why x times x is x squared. That's my area. Okay. For my triangle, If I want to calculate the area of a triangle, I take the base times the height and I divide it by 2. My base, 10p, times my height, 4p, divided by 2. What is 10 times 4? 40. And p times p is p squared all over 2. What is 40 divided by 2? 20. So my final answer is 20p squared. 20p squared. Okay. I'm going to skip C. It's a square. I'm going to do a word problem just because I think it's important. So I'll draw a picture for this one. It says a rectangle has a width of 5x to the 4th and a length of 5x cubed. If I want to find the area, I have to take the length, 5x cubed, times my width, 5x to the 4th. 5 times 5 is, everybody should know that, 5 times 5, 25. What happens to my exponents? What do I do to the base? If the base is the same, what do I do to my exponents? I add these. What is 3 plus 4? X to the 7th. Okay. Our last one is a parallelogram, and I don't feel like we've spent a lot of time doing area of a parallelogram. So I'm going to draw a picture and label it so you can see where that height and base measure live in a parallelogram. So here's my parallelogram. This is my height. This is the 4z to the 5th power. And my base is this 8z squared. The area of a parallelogram is just the base times the height. So my base, 8z squared times 4z to the 5th. 8 times 4 is 32. If the base is the same and I'm multiplying, I add the exponents. That gives me z to the what power? Z to the 7. Okay. So remember your homework. I'm going to just kind of write this up here so you guys know. So your homework is pages 5 through 7. Last name is A through M. You're doing 1 through 19 odds. And then choosing 2 of the 21, 22, 23. Whoops, sorry. Pick 2 of the word problems. If your last name is N through Z, you're doing 2 through 20 evens. And then you're also going to choose 2 of the 21, 22, and 23. Okay, so that's a total of 12 questions. That is a total of 12 questions.